Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 3A. Myself, Priyanshi Goyal, and this session would be moderated by. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2024, Ahmedabad, India. The eighth edition of the conference is being organized in a hybrid mode. The physical event was organized in Ahmedabad, India on 4th April 2024, and the virtual event is being held through Zoom today, that is 5th April 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session, Dr. Kalpesh M. Popat. Uh, Kalpesh sir is presently working as an assistant professor in Department of Mathematics at Saurashtra University, Rajkot, Gujarat, India. He has over 12 years of teaching experience and in worldwide journals with Scopus and SCI indexes, he has 12 research papers published. In both national and international conferences, he has delivered 11 papers. His areas of interest include graph theory, business and mathematical statistics, R programming, discrete mathematics, and more. We are very delighted to have you here with us, sir. A warm welcome to you.
Thank
Would
you
you
so
like to
much.
share welcoming words to the participants?
As you already said that all the paper presenter will be given 8 minutes and followed by 2 minute question and answer. So I request all the participants to stick the timing so that we can conclude within a given time. Thank you.
Thank you, sir. I also request the participants to be prepared with their presentations so that the session can go on smoothly. Also, please open your camera while you're presenting and answering the questions so that the chair knows whom they are speaking to. So, without any further ado, I would like to request the first person to present the paper today, Ma'am Vranda Jaru, to present her paper titled A Survey on Data Pre-Processing Techniques in Stream Mining. Do we have you here with us, ma'am?
Yes, ma'am.
Okay. So I'll stop sharing my screen so that you can share yours.
Fine. Is my screen visible, ma'am?
Yes, ma'am. No, wait a second. It's not visible yet. It's getting shared.
Is it visible now?
Yes, ma'am. Now it's visible. You may start presenting.
Okay, thank you, ma'am. Good afternoon to one and all present here. I'm Vranda Jaju, and I'm presenting my topic, a survey on data pre-processing techniques in stream mining. My co-author is Dr. Sanjay Tanwani, Professor and Head, SCSIT DAVV Indore. Starting with the introduction, data preprocessing is vital for effective data mining, especially when dealing with diverse data sources containing issues like missing values and errors. Tasks such as feature selection and normalization are essential for handling large data sets and ensuring data quality. And the result of the mining algorithm highly depend on the high quality of the training data. If we want to produce accurate results, then we should have accurate data to be processed. So the importance of pre-processing is highlighted because the is dependent on the quality of the data. It even becomes particularly crucial if we analyze high speed data with high volume. So the challenges in data pre-processing include big volume of data. With the advent of sensor technology and IoT, Internet of Things, The volume of the data is rising day by day, it is exponentially growing. So handling such big volume of data and pre-processing it is a big challenge. Then we come to second challenge, which is high velocity of data. If the data which is coming to us is not coming in a slow speed, it is coming with a high velocity. So if we want to analyze it, we cannot analyze it in just a single pass, because we cannot store it as of now, because it is coming with a high velocity. The third challenge which is coming is variety of data. The data may be structured, unstructured, semi structured. It can be from different sources in different formats. So pre-processing those data with different variety is again a big challenge. And the last challenge which comes here, last not the least, there may be other challenges also. These are the only listed few challenges, few major challenges. So the last challenges which I listed is concept drift. So concept drift means if when we input the data and there is a relationship between the input data and the target output data, so the target variable and the input variable has some relationship which changes over the time. So after some time that relationship if changes, then we need to change our models also. That is known as concept drift. So these are some challenges which we face while pre-processing the data. Now there are some techniques to pre-process the data, in which by pre-processing we mean that either we need to reduce the data or we need to make it error free, means we need to have an intact data. So the first procedure which we apply is data reduction techniques. We can reduce the data. Now data reduction can be done in two ways, because we cannot have we cannot analyze on such big amount of data, so we want to reduce it. So we can reduce it in two ways. The first one is a dimensionality reduction, and the second one is instance reduction. In dimensionality reduction, there may be many attributes of a data, and uh, all of the attributes which are available with the big data are not of that relevance to us when we are talking about analyzing the results, analyzing and giving the providing the results. So we need to project the data in a less dimensions. There may be so many dimensions, but we want to project those given data in less dimensions by selecting some of the features of the data. So we are not selecting all the attributes, we may project some attributes and we can have our analysis. But in that case we need to know that which are our attributes, which are the features which are actually having relevance with our research, or which are actually having relevance with our mining. So we can project those features only. This is one of the way. The process of identifying and removing as much irrelevant and redundant information as possible. The information which is not relevant to the current topic, to the current mining, can be identified and removed for analyzing purpose. So either we can remove the irrelevant data, or we can select the relevant data only. Both the ways we can do dimensionality reduction. Most of the algorithms in the literature for reduction are built as an advancement to the models working in batch processing. So previously also, when there was not a big data, we were having pre-processing in data mining also. We were having pre-processing as a step before mining the data. So but there was, the data was not big data, but so there was also some algorithm. But nowadays when we are working on big data, some algorithms were based on those algorithms only, which were working on the batch processing environment. Now feature selection algorithms built specifically for streaming data can be categorized into wrappers, filters, and hybrid. Now there is a step known as learning step. Whenever, suppose we are working on a classification mining or clustering, there are different applications of mining. So if we are working on classification, if we are working on clustering, then at the time of learning the model of classifying, or at the time of learning the model of clustering, at the time of learning, if we are selecting the features also, then those algorithms are categorized as wrappers. Distinguish to which, if we are at the time of learning, we are not filtering the data, we are not selecting the data, but the data filtering or the feature selection is a separate step, it is independent of the learning step, then such algorithms are known as filters. And if we are having both, if we are having the selection algorithm, working with the conjunction with learning step also and independent of the learning step also, then this way it is known as hybrid. Now, but there is another issue while we are reducing the dimensionality of any given data set, which is known as feature drift. At the time when we start the reduction of the dimensionality in any given data set, there may be possibility that there were only, let's say, 10 attributes, and at the time when we are reducing it, there may be addition of some extra attributes which may also be relevant. So the addition and removal of an attribute may be referred to as a feature drift. The features may be added or removed on the go, on the fly. So while analyzing and while pre-processing, we cannot say that these are the only X number. There are n number of features. The features may be n plus one, maybe n minus one during the pre-processing itself.
This is a gentle 1 minute reminder.
Okay. So, so the reason is that some attributes may have temporal relevance, or while some may gain relevance with respect to time, and the resultant is that the test feature space may differ from the training feature space. If we do not concern about feature drift, then the resultant may be different. So a conversion is needed of the feature space, and for this conversion can be done in three ways: lossy fixed, lossy local, and lossless homogenizing. In lossy fixed, for the one batch of data, the conversion is done and followed in all other batches. And in lossy local, for every batch of data, a new feature space is generated. And in lossless homogenizing, it considers both training and test data, which is the best case. Now coming to the next reduction technique, which is instance reduction. Instances, all instances are not good representative of the complete data, so we can remove some of the instances and reduce our data.
I'm sorry, ma'am. I would need to cut you in between. Can you please conclude the presentation? You have exceeded the time.
Okay. So the conclusion is that dealing with exponentially growing data sets poses new challenges, and in such scenario, it is very important to produce better mining results. And pre-processing is the first and foremost important step. We expect that our thorough study on these algorithms will help the researchers to gain deeper insight for overcoming. And in our future work, we intend to evolve a concrete methodology for pre-processing the data with lesser computational time and better accuracy. Thank you.
Thank you, ma'am. Are there any questions?
Like to comment that as I can see, you have presented the survey paper, is it? So, advice
Yes, sir.
nowadays it's less rather than you should do some research work. So,
Pardon?
I would like to say that you please do some research. This is just a survey, right? You
Yes,
get
sir.
it?
Yes, sir.
Yes. So I would like to advise you that you should do some research and you prepare some research paper. It's okay. It's a good paper.
Yes,
I
sir.
but nowadays a survey paper has less value than the research paper. So it is better that you
Yes, sir. It is just for getting the insights into the matter, and then we'll be
begin.
working for accuracy on some algorithms.
If you are a new in the research, then it is good. But if you're an experienced person, then I would prefer that you should prepare a research paper with survey paper.
Yes, sir. Thank you, sir.
Thank you, ma'am. Uh, yes. Moving forward, I would like to invite Afifa to present her paper titled AI in UI UX Design, a Paradigm Shift. Do we have her here with us?
Yes, hello. Good afternoon, everybody.
Good afternoon. Uh, I'll stop presenting so that you can present your paper.
Thank you so much.
Yes, I would like to request you to please turn on your video so that we can see. Yeah, continue.
Is my screen visible?
Yes, your screen is visible. You may start presenting.
Just 1 second. Yes, so my paper is AI in UI UX design, a paradigm shift. I'm the main author of FIFA, and I have two co-authors, Dr. Ramba Mishra and Pradeep Kumar sir. They are associate professors of NIT College, Noida. We know how artificial intelligence is absolutely taking over the world and how everything we see around is run somehow or one way or the other using artificial intelligence and machine learning. We know how our devices are heavily focused on artificial intelligence. We know how we have cars that are functioned by artificial intelligence. We have our homes run. Basically, everything and everything is using artificial intelligence nowadays. So, how about we use artificial intelligence in design process? We know how we have UI and UX design, which actually help designers to make the designs and front end designs of websites and our mobile apps. So, using artificial intelligence in streamlining those processes can help us create better designs and can help us create designs way faster and would take us less time and would make perfect results as well. Using artificial intelligence, we can even understand the user behavior and we can find out which way is actually the best way to present our designs that are actually useful for the users as well. First, we'll see what actually is UI UX. UI UX are crucial parts of a product designing, a website, or any mobile app. UI is basically how we have our layouts, how we have our buttons, how where do we press to get to somewhere. That is UI part. Now, what is UX? UX is basically user experience, the process where how we design and why have we put the button to a certain place. The reason for that, why we have used this particular design, is what is the job of a UX. Now, we'll see what are neural networks. Neural networks are computer systems that are heavily based on human brain. We have interconnected nodes, and these nodes help us make and create better results. These nodes are connected with each other, and with each node, we have certain weights assigned to them. These weights actually hold some value. That value helps us create better results and refine better results. Using these both the technologies, UI, UX, using artificial intelligence phenomenon, neural networks, we can make our design process way easier and streamline the design process. Now we have a perfect example of UX and UI. UX is why we decided to put something at a certain place. UI is how visually appealing you can make the design, because we want to attract humans as well to use our design. That's why we use UI. And why we need it, that's done by UX. Now, what is the need of using AI in UI UX? AI can actually help us create better results. It can help us understand better preferences, what people need, how can we provide to them. These are the things that are done by humans and it takes months. Now, in order to streamline that process, we can use artificial intelligence and create a software that can help humans make design in a very less period of time. AI can also help us convert our hand drawn sketches into UI elements that can also streamline the design process. I have reviewed 4 different papers on this particular phenomenon. First is evaluating AI approach for converting sketches into UI layouts. Second, we have a Grammarly for UI UX. Third is the impact of AI on design process. And fourth and lastly, user experience design using machine learning. These 4 different papers provide 4 different methodologies. First, we have UIZART. It is a software that is helping us convert hand-drawn sketches into UI layouts. It uses different kinds of algorithms. Secondly, we have a prompt that can rectify our design mistakes. It can help us tell that this place has alignment issues, or this place or this color is not complementing the other color that is used. Thirdly, we have leveraging the text to design, similar to how we have a software right now running, that is Dolly. Lastly, we have using machine learning to train our model to generate a UI that is based on a user's preference. The result we have taken from these review papers are that Implementing UI can actually help us create a design process that is way easier and way faster. Methodology. How can we actually convert our sketches into designs? We have several phenomenons like CNNs, that is conventional neural networks. We have GANs that uses two different parts. One is a generator and the other is a discriminator. During a training, the generator actually converts the generator actually creates a data which is not actual the current data. First, we provide our GANs with the actual result, that is our actual answer. Now, the generator produces an answer. The job of a discriminator is to actually find out if the actual answer matches the result that was proposed by the generator. Using these both the phenomenons, we can find out what actually is the actual result. And is our machine actually capable of generating a result that is similar to the actual answer? Text to design is also done using diffusion. What diffusion does is it creates an image that is of low resolution. And iteration process helps us to create an image with realistic textures and different kinds of details. This is the basic functionality that here we have a hand-on sketch, which is converted successfully into a mobile design using a phenomenon UI's art. As a conclusion, I would like to say is that AI actually helps us in creating different processes very easily. But there's one thing we need to understand is that AI cannot actually help us create everything and anything. We need humans for doing certain things, but we can definitely use AI to streamline that process, make something way much better, make something way much faster. But obviously, we need humans as well to make the design actually functional. And the end product is obviously the human who's going to use our actual product. For its future scope, we have come across, since I have read a lot of research papers regarding the same thing, and I have concluded that there are very limited researches based on this. We only have few softwares running in the market that actually help us make UI designs. We have softwares like DALI, Sara that actually make text, that actually create images from text, but we do not really have many softwares that help us create UI designs, which are mobile designs and our website designs using AI. So I think definitely the market can work on this and we can come to a different and a better conclusion regarding conversion of text into UI designs rather than just images. Thank you so much. And I would happy if you can ask me any questions regarding this.
Yeah, no question from my side.
Okay, thank you so much, sir.
Thank you, Afifa.
Thank you.
Next up, sorry, just give me a minute. Yes. Next up, I would like to invite Subramanya Hemant to present his paper titled An Improved Email Spam Classification System Using Random Forest Classifier. Hemant, do we have you here with us?
Yeah, I'm here. Just give me a second.
Yeah. Yes, your screen is visible. You may start presenting.
Yeah, is my screen visible?
Yes, it is visible. You may start presenting.
Yeah, yes. So, good afternoon, the judge. I am Hemant from SRM Institute of Science and Technology, currently pursuing my third year BTech. And my paper is titled An Improved Email Spam Classification System Using Random Forest Classifier. I am the first author, and my guide is Dr. Kalyan Niti, Senior Scientist, CSIR NGRI, Hyderabad. So, the basic outline of my paper goes like this. The basic introduction. The problem is that the problem statement we have chosen is that the growing threat of spam emails and limitation of traditional filtering methods. So basically, may it be a business, may it be an educational institution, emails are the heart of communication for formal communication. So there's a lot of spam going on in emails where there's data theft, intellectual property theft, and even privacy issues rising. So the solution would be using random forest classifier, a machine learning approach for improved spam detection. So the methodology is I'd be explaining the random forest, the methods we have used using decision trees, and even including this hyper parameter tuning. So the implementation is this software libraries use the scikit-learn and training the model with label data. Label data in the sense the data sets are labeled beforehand to train the model on the basis of which email is spam and which is a legitimate email. So the evaluation metrics go like this: accuracy. We have plotted a true true and false negative graph. We have also plotted the conversion matrix, and we have also plotted the ROC AUC score. The results are as follows. Performance of model achieved accuracy on training and test data, visualization of results using conversion matrix and ROC curve optimization. Limitations. The limitations of my modeling are accuracy, and there is a great potential for improvement. And the model might not be aware of any unseen spam tactics. So future work of this model include feature importance and even implementing this machine learning model along with AI, so that one of the limitations is satisfied, and testing against diverse data sets and broader adaptability. So going on to introduction. So what is an email? Email is a modern communication tool, and it has become a lifeline for many institutions, businesses to communicate formally. So while email appears user-friendly, it functions through a complex network of servers and protocols that ensure message delivery. There lies a loophole that anybody who has an email address can send an email address to anybody in the world. So this is a vulnerability. Like any new technology, email is also susceptible to misuse, as I mentioned earlier. So the fraudsters exploit mails for scamming people and like phishing, causing financial and data losses. Benefits outweigh the drawbacks. So considering the matter of fact that email has helped many industries grow, uh, but there are drawbacks also, which are outweighed by the benefits that email gives us. So despite the risks, email's advantage in communication outweigh the downsides of spamming and phishing. So the used methodology is random forests are a machine learning technique that combines multiple decision trees for improved accuracy and robustness in predictions. So the building blocks rely on concepts like decision trees, Ansible methods, using random subsets of data, and random forest algorithm itself. So the algorithm in action is we set a hyperparameters, that which means that we control how the model learns and utilizes the CPU power. Utilizing bootstrap sampling, randomly selecting the data with replacement for training. So this is the thing we do in training, that we replace the existing data sets with random data to check the accuracy. And we also create an out-of-bag sample, data not used in training for evaluation. So once we have completed a data set, to test whether it is working up to the mark or no, we create an out-of-bag sample and we bring that out of random and train the model and test for accuracy. Then making predictions through averaging or majority vote. So uh, to classify whether an email is a spam or a legitimate email, we make predictions by averaging the spam or the content in the email, or by voting majority that the machine learning model learns. So cross validation. We also cross validate our existing model using out of bag sample uh, by testing it with other standard models of email spam filtering. So the benefits of random forest classifier are as follows. They offer accuracy, robustness, interoperability, and they also understand how they they make decision trees. And hyperparameters. These are the settings that control how a random forest learns. So while making predictions, the ultimate goal of the model is to make predictions and to tell us whether an email is a spam or a legitimate email. Random forests can make predictions by averaging the outputs of all the trees, regression tags, or by majority vote classification tags. So implementation. The essential libraries involved in this model are random forest model, relies on Python libraries like NumPy,
हमारा
Pandas.
बर्ड्स कनेक्ट करा था सवारे में करा था बर्ड्स कनेक्ट बीजा से बीजा सेशन સુધી તો બર્ड्स रहा हमारा
I'm sorry.
Yeah, no. So the implementation essential libraries of this model include random forest model that relies on Python libraries like NumPy, Pandas, Matplotlib, and scikit-learn for data manipulation, visualization, and machine learning functionalities. Random forest is a versatile tool that is a powerful machine learning algorithm that can handle both classification and regression. They are rooted in decision trees and are widely used in various fields. The implementation, the spam filtering using random forests. In email filtering, random forests excel at distinguishing spam emails from legitimate ones. This is an improvement over traditional methods like whitelisting
This
and
is a
blacklisting.
1 minute gentle reminder.
So the results would include the conversion matrix for the model is shown in the figure. The plot of false positive rate minus true positive rate has been improved when compared with the existing whitelisting and blacklisting model. So the limitations of my model include accuracy. While the paper mentions promising accuracy rates, there is likely a room for improvement. Sensitivity to unseen tactics, as I mentioned earlier, spam, the data sets, the model is only trained on data sets. So any unforeseen conditions or any unforeseen spam tactics cannot be detected. Limited data set scope. As there is a limited data set scope, the model's performance might be limited. And while random forest offers some interoperability, the decision-making process within each tree can be complex. Depending on the implementation, it might be challenging to fully understand why the model classifies a particular email as a spam or as a legitimate as well. So the future work would include testing against diverse spam data sets, uh, using artificial intelligence along with machine learning, as mentioned earlier, and take this tool to a B2B level and for monetization. So the study investigated use of random forest for email class filtering. While the model achieved promising accuracy results, further analysis is crucial to optimize its performance. Testing against diverse spam datasets would showcase models' adaptability to various spam tactics. So overall, while promising, the model requires further refinement to be truly robust and reliable solution for email spam filtering because it has been trained in various datasets. So these are the references, and thank you so much. Any questions?
Yes. So my first question is whether this model is developed by you or you are presenting the model which is already developed.
It is I have used the random forest which is already developed. Using that, I have developed the model and trained the model using different data sets.
Because you have written an improved email, right? So it is an improved model. I can say that. Is it?
Yes, sir. With comparing, the previous models, this is an improved email spam classification.
How it differs from the existing model?
Sir, it differs. Like there was no hyperparameter tuning in the previous models, and there was also no majority voting on which email is legitimate or spam. As I mentioned, that we cannot accurately tell why the model declared an email as a spam or why it put it as a legitimate. So using this hyperparameter tuning, we can uh, get even more accurate results on why
So what is your
our
accuracy of your model and what is the accuracy of existing model?
accuracy. I'm not clear on accuracy, sir, but when we when we plotted the graph against false positives and true positives, our model was way a lot better than existing models. So which meant that it was better than existing models.
Matter if you are developing, if you are improving some model, then if accuracy increasing, then we can say your model is good than the other model. So
Yes, sir.
yes, and which statistical technique you are using and finding the accuracy?
We are using we are training the model on various data sets and
Yeah.
then testing it to get the results, whether it is working up to the mark which we put.
Okay. Okay. Thank you.
Thank you so much.
Thank you, Subramanian. I would now like to request uh, Sir Sharad Kumar to kindly present his paper titled Comparative Analysis and Study of Technology Approach to Document Image Understanding from Structured Text Document Image. Sir, do we have you with us here?
Okay, I'm sharing the screen.
Yeah, you can. Just a second. I'll stop this. Yes, we can. Yes, the screen is visible. You may start presenting.
Okay. Hello, everyone. I'm Sarad Gimire. I'm going to present our paper that is Comparative Analysis and Study of Technology Approach to Document Image Understanding from Structured Text Document Image. And we are three authors, Vishal Basal, Janak Sharma, and me, myself, Sarad Kumar Gimire. And we are from the Department of Electronics and Computer Engineering, Pulsar Campus, Institute of Engineering, Trivandrum University, Nepal. First of all, let's see what is DIU. DIU means actually document image understanding, and actually it means the extraction of meaningful information or insights from the structured text document images. And it involves actually development of several algorithms and systems that is capable of extracting meaningful information from scanned or digital document images. For example, in this invoice, there might be several informations. So as an insight, we can see bill to whom or what is the total amount and bill to from whom and so on, this kind of information, or even invoice number and others. So what is the structured document? It means actually structure means well-defined structure. So structured documents have some predefined format, typically in the form of some table or forms or like database, and they contain clearly defined or labeled data. Examples of structured document include like invoices or financial statements and some medical records and so on. The structure allows for easy processing, analysis, and automation of data. And for example, here we can see that this one shows the actually like National Football League, this might be different address and value, so on. Similarly, in this part of this document, it shows the employee identification number, their telephone number, and so on. So from this structured document, we can extract different information from different portion of this image. So for rest of the part, I want to request our author, Vishal Basal.
Now let's dive into the need of DIU challenge and now
I'm sorry, you are not audible.
am I audible?
Yes, but your voice is it's repeating again. It's echoing.
Is it okay now?
Yeah, it's better.
Okay, so traditionally we used to manually digitize the documents, and it was financially inefficient, but the actual need of DIU comes into the fact that huge amount of information and insights can be generated by context-oriented application of DIU. There are several methods. However, the efficiency of those approaches is specific to a specific kind of structured document image, which brings us to the need to analyze various deep learning approaches as presented in this paper. And in related works, this first related work presented a comparison of RCNN, faster RCNN, which are only based on mean average precision, which does not dive into modern deal approaches. The second related work only focused on Swedish and handwritten documents, which could not be generalized to other structured text document images. And the third related work did a theoretical review, but lacked numerical results. Now, I'd like to break down the components of DAU into two sections. The first is the building block, where we have general components in DIU pipeline incorporated in most DIU applications. The second section refers to the downstream tasks. In image processing, we try to refine the image before giving it to the OCR so that the OCR results are more effective. In layout analysis, we try to understand the structural arrangement of elements within a document. And in OCR, we try to understand the positional data as well as the actual characters present within that specific image. It is one of the preliminary steps. In text extraction, we focus on NLP and understanding the semantic and meaning context of that specific text in the document. Now, this is the section of downstream tasks. This is the actual useful work. One of the useful work could be document classification, which refers to classifying a document into an AND class classifier. Let's say if a document belongs to which class could be one of the tasks. Information extraction, as shown in the previous slide, could be the extraction of specific insights. Semantic analysis refers to understanding the actual meaning of a word in a specific context. Let's say in revenue of Apple, Apple means company. In taste of Apple, Apple means fruit. So something like this. In multimodal analysis, we're referring to analyzing not just text, but also the visual elements for better downstream tasks and performance analysis in the future sections. This is a generic approach to DIU diagram. In the first pipeline, we see a training approach where Tesseract is giving OCR data and we are building annotation to train the model. And however, in the second pipeline, we are actually using the model to build our DIU application and downstream tasks. Traditionally, OCRs and rule-based methods have been used for digitizing documents. One of the limitations is that they are strict to a specific kind of document and cannot be generalized to other specific kinds of documents. However, in the modern approaches, we see that they are able to train on a specific kind of document and can be fine-tuned to work on various other data sets. One of the examples of deep learning approaches is layout LM, which adds 2D positional embeddings and image embeddings. Masked visual language model basically refers that the visual sections and even the text section is masked by the model, and it tries to predict that specific masked section. In LILT, we train the model on a specific language document, and then we can fine-tune it to work on multiple languages, and hence making the model multilingual adaptable. In StockText V2, we're trying to eliminate the necessity of OCR pre-processing. It basically includes two pre-training tasks, masked language modeling and masked image modeling, which basically means predicting by masking that specific part of the document. In OCR-free DUT, we are looking at end-to-end model where we feed the raw image and get the output. In DocFarmer, we are looking at a multimodal self-attention layer where attention values is associated with the text as well as the images section. In Ordinary layout, we are looking at especially where this attention mechanism, which learns to focus on different parts of an image independently, considering both their spatial positions and features. Finally, this is the results. We see that layout LM performs better in form understanding tasks. LILT performs better in semantic entity recognition. StockText V2 performs better in document image classification. OCR-free DUT in information extraction. DocFarmer in sequence leveling and entity extraction. Ordinary layout on key information extraction tasks. And they are associated dataset where the model has been tested on. The limitations, however, of this is that benchmarking against a single standard data set for all deep learning model approaches is complicated, as it does not give enough insights about the actual application of the approach where the model approach is suitable. Similarly, like what we have done, performance analysis under multiple data sets is feasible. However, the metrics may not be accurate representation when the benchmarking data is of varied count and from varied sources. For example, we are looking at FUNST, SROIE, CORD, and other kinds of data sets. Future works include analyzing the performance of document image understanding based on LLMs and generative AI across variety of data sets. And one of the things that we are really looking forward to in the field of DIU is establishing a comprehensive benchmarking dataset and evaluation framework that can more accurately represent the performance of document understanding system across a variety of real-world scenarios and document types. Finally, concluding our research, this analysis and study serves as a foundation for informed decision-making in choosing the pipeline and suitable methods for specific DIU applications, and more advancements in this field will undoubtedly contribute to the development of robust and versatile document understanding systems. These are our references. Thank you so much. Any questions?
Yes. So one thing I would like to ask, that the title is comparative analysis. In comparative analysis, you are comparing two algorithms or two methods or two models. So is
Yes.
it Is it like this in your presentation, or you have presented a research?
Can you repeat the question?
The question is, your title of the presentation is comparative analysis. In comparative analysis, you are comparing two algorithm or two model. So
Yes, yes.
is it so you have presented?
Y-
Because I have not seen any two model or more than two
y-
models.
Um, so if we go into the results slide, you can see that we have compared the performance with precision recall and F1 score of these multiple models, and we are concluding that these specific models work best on these downstream tasks as shown in the results. We have also discussed this previously in the slide.
Excellent, very good. I would like to congratulate for a great presentation. Thank you.
Thank you so much.
Priyanshi, are you there?
Yes, sir.
Oh,
Hello.
yes, sorry. My mic was. I would like to request Divyanshi Srivastava to kindly present your paper titled Crime Data Analysis.
Yes, ma'am.
Do we have you here with us,
Yes.
Divyanshi?
Yes, ma'am.
Okay, I'll stop presenting so that you can present.
Yeah. Is my screen visible?
Yes, it's visible. You may start presenting.
Yeah, just a second. Yeah, so good afternoon, all the esteemed members present here today. I'm Divyanshi Srivastava, and I will be presenting on the topic crime data analysis. And my co-authors are Ujjwal Kumar Jha and Mr. Paurav Balania, who is also my guide. So the introduction to this topic will be that crime is today a very crucial concept, very crucial aspect of modern law enforcement, and the criminal justice systems are not at all fine right now. So the concerning trend today is that there's a recent increase in crime rate in all the areas. The factors that influence the crime rates are economic instability, social inequality, and many demographic shifts. So what we have done is that machine learning is a increasing trend these days. So we have used the techniques which have emerged as a powerful tools. These tools are used to extract valuable insights from large and complex crime data sets, because criminal data sets are really huge and complex. This enables the identification of hidden patterns and the correlations between the crimes that might occur. Moving forward, machine learning and criminal analysis would be that machine learning algorithms, these are used to analyze any historical crime data that has been existing, and this helps us further identifying the patterns to predict where the crimes have actually occurred and where they are likely to occur in future as well. Natural language processing, NLP techniques, these are used to analyze and categorize a very large volume of data, because criminal data sets are really huge. So we use NLP techniques. These includes police reports, they have witness statements that have given witnesses, and much more than that. So these techniques extract valuable insights from this data for criminal investigations and further what the system can do. Sentiment analysis is a subset of NLP. So this is used to analyze what is the sentimental aspect of the text data that is present in the historical criminal records. The machine learning algorithms that are utilized in analyzing all the forensic evidence that is present. These could be DNA samples, fingerprints, and all the ballistic data. This links to the suspects that are accused for any criminal activity. The approach of the project is to collect the criminal data and clean it properly. Then we further move on to the exploratory data analysis. This will help to understand what is the crime distribution in any particular area, and check if there are any patterns that are repeatedly occurring in that area. Then we would integrate the data set with with other aspects, be it demographic information and geospatial analysis, to identify what are the criminal hotspots in where the crime is being occurred. Then we would choose the most appropriate classification algorithm to predict what is the type of crime, and a regression algorithm to predict what is the crime rate. The methodology that has been used here is that we have used clustering and pattern recognition
for grouping the crimes based on their types. Like one crime might be a part of another crime as well. So we have used that to group it. Then we have moved forward to anomaly detection to find what are the outliers, which might be unusual crimes or any crime that has been emerging in the new time. Then we move on to interpretability analysis. This gives us a detailed understanding about the factors that are causing crime and how they can be seen. Further, we move to deploying the trained models into the system that can be used by law enforcement. Then testing is done and we provide an easy user interface so that people who are even not from a proper technical background can easily understand the UX and work on it. This is the per chart for what I did in the model. So it includes the phases, the weeks, and which is divided. We do the project planning, then we do data integration and data gathering, then we perform testing and training, then we move forward to predictive analysis, which takes time. Then we see if there is any pattern recognition. We use clustering and pattern recognition for that. Then we move forward to anomaly detection. Then we secure the data because it's a highly confidential data that needs to be secured. Then we move on to interpretability and deployment. And then we check the model by alpha and beta testing to improve and enhance if there's any scope. The advantages of this model will be that it will address to public and keep them safe. And it is good for decision making, as all the decisions that are being making is not manual and it is data driven. The investigation processes will be enhanced. It will help the law. It will also help people and the law to identify the crime hotspot that has been prevalent in the few years. And it will also help in policy and strategy development to the law enforcement so that they can take better actions. And the response time will be less since it's not being handled manually. So response time will be less. Then moving forward to the results. The results we got is that we'll be displaying the state-wise record for all the crime data and criminal victims. The idea behind this is that we create a platform where law enforcement is given a login user ID and password. Using this, they will be redirected to the portal to access any cases information, which would in turn help the police and law enforcement to create a forum and also review status for all the ongoing cases and refer to them for any criminal activities or any hotspot area, and they can refer to the crimes that have occurred previously there. The visualization of this project is that there are cases that are displayed according to the states and according to the age as well. We have taken data for 10 years. This will help the law identify prevalent crimes and what age group is targeted, what area is targeted, everything. Using charts and graphs, it will show a clearer picture to everybody to show what is the current status. With that, I would like to conclude is that the model will have a high accuracy degree, which will help identify the crime. All the graphical representations that we will use will help draw a clearer picture. And the study will in turn provide a framework outlining on how all the components of machine learning will contribute to the development of this system so that it will be significantly more helpful to the law in case solving and building a safe community. We will offer an estimate future crime trends that will aid in the identification of previous crime prone location with all the alerts. The crime analysis can be used in the department for a very long-term planning effort because crimes are not going to stop. And this will help in turn create a safe and a secure society. These are the references that I have used for this project. And that will be all from my side. And I'm open to all the questions.
Yes, so my first question is, have you tested this model on any data set?
Yes, sir. I have tested this model on the data set. I have.
You have not mentioned the number.
Sorry, sir.
What will be the accuracy of this model? You have
Yes, sir. Sir, I have used various algorithms in this model. The accuracy is different for all the algorithms. I have used decision tree. I have used KNN. I have used random forest. The highest accuracy with the accuracy of 87% was there in the KNN algorithm that I used.
and what statistical technique you are using for predictive analysis?
Sir, we have
committed a crime or not? How you can judge?
sorry, sir. Didn't get you.
Yes, I am saying that in predictive analysis, which statistical technique you are using?
To judge whether the crime is occurred or not.
Yes.
Yeah, so we have actually the criminal data set is really huge. So we have taken a section of criminal data set for a particular state, and we have taken a CSV file for it. And we have taken from year 2001 to 2010, and we have seen the crime rates that have been prevalent. And according to that, we have
Which technique you are? Can you name the technique name, of statistical technique that you are using in predictive analysis? I have a data set, then I want to predict whether a person has committed a crime or not. Then I have to do some statistical analysis. I'm
uh,
asking which technique you are using. Have you heard the name logistic regression?
yes, sir. Yes, sir. We have used regression as well.
Would be the better, and I think it can be useful for
Yes,
the.
sir. Yes, sir. It is logistic regression that we have used, and we have also seen. We have also used SVM, and we have compared it according to that, both of them.
Yes, yes, yes. Okay,
Yes, sir.
okay. Thank you so much.
Yes, sir. Thank you so much.
Thank you, Divyanshi.
Thank you so much, ma'am.
I would now like to invite Satakshi Chatterjee ma'am to present a paper titled Intention to Adopt AI-Enabled Manpower Planning for Patient Satisfaction, an Empirical Study on Future-Based Technology. Do we have you here with us, ma'am?
Yes, I'm present. Good afternoon,
You're,
everyone.
yes, you're like, you're not easily audible.
Is it better now?
A little, but okay.
Please let me know if the audio is not.
If you can be louder, that would help.
All right, all right.
But we are getting very low voice from your side. I think it is because you are using the earplug. So better if you
Yes.
speak without the wire, then
Sir, then there will be a lot of background noise. I don't mind it if you are okay with
okay,
it.
okay. Now I'm getting your clear voice. Okay, continue.
Okay, okay.
Thank you.
I'll be a little bit louder. Thank you so much. So with your permission, sir, I'm starting my presentation. I hope my screen is visible.
Yes, it's visible.
Yes,
You
yes.
may start.
So today I will be presenting on the topic intention to adopt AI-enabled manpower planning for patient satisfaction, an empirical study on future-based technology. So before moving forward, health is a very essential necessity today. And of course, if I'm talking about the rural parts of India, then the accessibility to quality healthcare services are an issue. So this area basically lack in channels of information, which could be resulting a huge chaotic situations for the people residing in those areas. Now, these problems could stem from a lack of infrastructure as well as manpower as well, since we are all aware of the fact that healthcare is a service-driven industry, and the quality of healthcare services majorly depends on the human resources per se. Now, before we move on to the actual paper, just highlighting the rural healthcare system of India. So basically, we have three stages over here. The first one, which is the most peripheral point of contact, is that of the sub-centers. Now, again, there are certain requirements of human resources, which is mentioned over here. That is one healthcare worker, female, auxiliary nurse, midwives, and one healthcare worker, male, followed by a primary healthcare center, which is a referral unit of 6 sub-centers, and they are basically 4 to 6 bedded hospitals, and they have to be manned with a medical officer in charge with 14 subordinate paramedical staff, and then followed by your community healthcare center, which is a minimum 30 bedded hospitals, and they basically are there for 4 PHCs, and CHCs is the only point wherein there is a delivery of the specialized healthcare services per se. Now, the objective of this paper is to identify the factors about the adoption behavior of AI-enabled manpower planning in the healthcare systems of in the healthcare centers of rural West Bengal. Now, over here, right at the onset, I would just like to point out that we have only considered the CHCs over here, that is the community healthcare centers, and not the sub-centers and the peripheral primary healthcare centers. Now, again, coming to the review of literature for our hypothesized research model, and by going through the literature, we have used two different models over here. The first one is that behavioral reasoning theory, which is known as BRT, and augmented technology acceptance model, which is also known as TAM. Now, under this, we have seen, according to the behavioral reasoning theory, there is this values and beliefs, and this values and beliefs were seen to have an impact on the reasons for and reasons against of embracing the new technology, which in this case is the AI-enabled manpower planning system. Now, under the reasons for embracing the new technology, we have used constructs like perceived ease of use, perceived usefulness, and perceived enjoyment. So all of these three constructs are taken from the augmented TAM model. And for the reasons against, we have taken the three parameters, that is cost barriers, risk barriers, and the usage barriers. And ultimately, they were found to impact the attitude of the individuals who were supposed to adapt to this new technology. And finally, there was a impact on the intention to adopt also, which is a part of the consumer behavior per se. And we have used over here market awareness as a moderator between two associations. So over here, we have 9 hypotheses, which we have already talked about. And this was our hypothesized research model, which we went for analysis. Now, coming to the research methodology part, we have used a cross-sectional descriptive research design over here. Both primary and secondary data was used. For secondary data, we have browsed various literature starting from research paper, books, and various articles on the same thing. And for the primary data, it was collected from the various administrative personnel who were in charge of manpower planning or human resource planning in the community healthcare centers of India. So this respondents included the block medical officers or medical superintendents and so on and so forth. The sample size was 291. So basically, we conducted the structural equational modeling, and it was executed with the help of the statistical tools of SPSS 28 and AMOS 28. So before we went forward with the actual analysis, a pilot study was conducted, about 15 respondents. And then also, I forgot to mention, we have used the convenient sampling technique in order to collect this data, and the sample size, as I just said, it was 291. Now, coming to the data analysis, it was a two-step approach. So first, we conducted the confirmatory factor analysis, wherein we analyzed the measurement model for say. Under the same thing, we measured the validity and the reliability of the data set. And in the second step, we basically designed the structural model, and we tested it out with the help of structural equational modeling. And also for the moderation analysis, we have used process macros. Now, before we went on with the actual analysis, it was very important to find out whether the data set is having any kind of common method bias or not. There should not be any kind of biasness regarding the same. So again, there were various parameters which was followed, and the test which was conducted was the Herman single factor test. And as the threshold range basically said that the results should be less than 50%, so that's what we got. We got a value of 32.839% of variance, and which was indicative of the fact that common method bias was not present in the study. Then we conducted the reliability test with Cronbach alpha, and of course, it was found to be greater than 0.70, which was indicative that which proved basically that there was this internal consistency of the primary data set. This was our measurement model, and as you can see over here, the fitness value, all are coming within the range of the recommended values, which further told us that we can proceed with the designing of the measurement model per se. So again, the confirmatory factor analysis was also conducted over here. And again, as you can see, all the threshold ranges over here, starting from AB, ECR, MSP, ASP, everything was matching. Then coming to the structural model, so we basically wanted to check the fitness values of the structural model as well, and they were also within the recommended values. And finally, coming to the path analysis of the research model, all the 8 analysis, barring the moderation analysis, that hypothesis, I'm coming to that later. But amongst that 8 hypotheses that we have calculated, only one did not return any kind of result. The other 7 hypotheses were all proved true. And this is the moderation analysis, wherein the moderation was found to be significant in the first 2 instances, but not in the third instance. Now, again,
This is a
coming to the
gentle 1-minute reminder.
yeah, I'll just wrap up. So coming to the findings and discussions, so there was no relationship which was found between the value and belief system with that of the attitude, because many of the people specifically who were practicing in the rural belt, they were not aware of such systems. So as a result of that, they lacked the drive to train themselves and upgrade their skills. So coming to the implications, so in the future, if such a system would be utilized, then whatever manpower inventory we have with us, the healthcare centers had with us, so they can be utilized in an effective manner, and further on, they can plan the recruitment and the selection processes also in the future in a very pertinent manner. Limitations of the study was that only the data was collected from West Bengal. So later on in the future scope of study, we can expand the study to other states and union territories of India, and even we can go for a global study wherein we can do some kind of comparative analysis per se. And concluding my research paper, so of course, using high-end technology is something which is very important, which is becoming very important across all domains of business today. And the same could be applied in the case of healthcare system, particularly in the case of rural systems, wherein we are facing a shortage of manpower, of human resources. And the issue over here is that people do not want to stay in the rural, areas of India because there is a lack of facilities and because of certain other results. So again, with this particular study, this problem can be taken care of to a certain extent. So that brings me to my to the end of this presentation. Thank you so much for your patient listening. Now I am open to any kind of questions.
Yes, first of all, I would like to congratulate for wonderful presentation. It was a nice statistical numbers that I see.
Thank you.
I would like to ask you the question that which statistical tool you are using to find these old numbers?
Sir, didn't get you, sir.
Pardon?
Sir, didn't get you. I was unable to hear you, sir.
Yeah,
Your
I'm
question.
asking that which statistical tool you are using? Are you using R programming, SPSS, or which?
SPSS, sir. SPSS 28.0 and AMOS 28.0.
Okay, and you are already mentioned that you have collected data from West Bengal only.
Yes, sir.
So you would have a sampling error. So this number might change if you are collecting data from if you are, because when you are taking sample, you have to take care that the sample should represent the populations.
Yes.
So it is, you need to take the diversified sample rather than just one taking sample from one state. I understand
Yes.
there are limitations, there are, you
Yes,
need power, you need money, or it is time consuming. But anyways, this is a wonderful presentation.
Thank you, sir. I'll keep that in mind, sir, and I'll try to expand this study later on in the future. It's just that, sir, it's very difficult to collect the data
Yes,
from
yes.
the
I
rural
understand because
regions.
I know statistic that how to collect data. It's quite an extreme task.
And not only that, sir, separating the erroneous part, that is again another headache. But anyway, sir, thank you so much for your valuable inputs. I'll try to take it up in the next
My
page.
pleasure. Thank you.
Thank you, sir. Thank you so much.
Thank you, ma'am.
Thank
I
you
would
so much.
now like to invite Sir D.S. Sanjay to present his paper titled Multi-Object Segmentation and Tracking System on Zinc Ultrascale Plus MPSOC. Do we have you here with us, sir?
Yeah, hello. Am I audible?
Can you be louder?
Am I audible now?
Yeah, better. Just
Yeah.
try to be a little louder.
Sure. Can I share my screen?
Yeah, you can share your screen.
Is my screen visible?
Yes, your screen is visible. You may start.
Yeah. Hello everyone, my name is Sanjay and today I'm presenting our work multi-object segmentation and tracking system using Zinc Ultrascale MPSOC. So the paper ID is 115. So coming to the abstract of this work, so with the increase of edge computing systems in the ADAS industry, implementation of a prominent applications such as multi-object segmentation and tracking is very much a challenge for the developers and the industry people. So our paper focuses on implementing multi-object segmentation and tracking systems on the Zinc Ultrascale MPSOC ZC104. So before getting into the work, let's understand why we need the segmentation. Segmentation provides pixel-level precision, distinguishes between different instances, and also it can handle occlusions more effectively
when compared to the bounding boxes as in the object detection. Now let's get into the applications of the tracking. Tracking is widely used in the surveillances and securities, autonomous vehicles, and sports analysis, which we have seen in the World Cup and also in the IPL. So coming to the related works, there are several works that have implemented the object detection and tracking system on the Zinc SoC, but they do lack in some of the concepts. So let's get into that. So here is one such example: real-time embedded object detection and tracking system. So this work uses SSD model, and this model is deployed in the programmable logic, and the KCF tracking algorithm is deployed in the processing system. So both of these model and as well as the algorithm is comparatively lightweight, and thus improves the processing speed but compromises the accuracy highly. And the second such work is again a same hardware software approach, which uses fully connected SAMIS tracker, where again the detection part is deployed on the programmable logic and the tracking part is deployed on the processing system. Now this SAMIS tracker is a neural network, so it's a comparatively high weight model. So it provides better accuracy, but is slow in processing. So with this analysis, we can get to know that there is a trade-off between the processing speed and the accuracy. And both of these work doesn't use the state-of-the-art models such as YOLO and or the other tracking algorithms. So we thought of using the state-of-the-art models, where again, we also have YOLO V9 now, but at the time of research and paper submission, the YOLO V8 was the one of the efficient model for real-time object segmentation and detection. So there are several sizes of this YOLO V8 segmentation model. So we based on our application, that is, we have to use it in a edge computing device. So we are using YOLO V8 and Seg Nano, but the .pt file is not optimized for the edge computing device. So we have to convert it into ONNX model and then to the TensorFlow model and then to the TF Lite in order to make it optimized and suitable for the edge computing device. So coming to the tracking algorithm, we have the deep OC sort. In this, it uses the object detector to detect the object first, and then motion-based association to track the objects based on the feature vectors and the bounding boxes. And it also has appearance-based re-identification in order to improve the tracking process. And then we also have the strong sort, wherein it first uses the appearance feature extractor, that is the ResNet 50, and then uses a Kalman filter for nonlinear motion, and also uses a camera motion correction using enhanced correlation coefficient. Now, again, we'll be comparing these algorithms, how these algorithms perform in the coming slides. So let's look at the Zinc ultrascale MPSOC architecture. So it has a processing system here and a programmable logic. The programmable logic consists of the FPGA, and the processing system consists of quad-core ARM Cortex A53 with the DDR4 2 GB, 4 of those DDR4 RAMs. So this is the architecture with the processing system and the programmable logic, wherein our solution lies in the processing system, which uses the quad-core ARM Cortex A53. So YOLO V8 segmentation model is present in this, and also the tracking algorithm. The input video from the microSD card is fed into the YOLO V8 segmentation model, where the segmentation takes place. The segmented output is then given to the tracking algorithm, where the tracking process takes place, and then the output video is saved in the microSD card. So here is the output of deep OC sort. So this video contains several cases which I would like to highlight. Now I would like you all to concentrate on the ID 19 person. So now there is another ID 23. Now, as you can see, ID 23 was changed to ID 19 and then re-identified as ID 23, which is a very good general re-identification performed by the deep OC sort. Now is the output of the strong OC sort. So again, I would like you to concentrate on the black t-shirt person who has ID 8 for now. Now it has been changed to ID 33. And that ID 33 has been given to a new person, which is failure of re-identification in the general case. Now there is another case of occlusion in this video. So as you can see, due to the occlusion, the segmentation model has failed to identify these people as person. So now here the ID 7 person is re-identified as ID 7 in the output of the I mean to say ID 3 person has been has failed to re-identify as ID 3 in the deep OC sort, whereas in the strong sort, the ID3 person has been re-identified as ID3. So in this case, in the case of occlusion, strong sort performs better than the deep OC sort. And there is also general re-identification, as I was talking earlier. So deep OC sort has identified total 31 objects or the persons in this case, whereas the strong sort has re-identified with the ID 52, which is the strong sort fails in the general re-identification. So the conclusion of this work is that this work successfully leveraged the capabilities of Zinc UltraScale MP SOX ZCU board and in order to implement the object segmentation and tracking system. And this solution paves a way to develop and deploy such efficient and reliable computer vision solutions on the embedded systems and the MP SOX. And also the future, coming to the future scope, what we have done is we have used the YOLO V8, which didn't have int8 quantization support earlier. So we had used F16, so we couldn't use the programmable logic of the board. So with the recently released int8 quantization support of the YOLO V8, we can use the programmable logic by converting the int8 YOLO V8 int8 quantization into .x model, which is supported by the Xilinx boards. So using that .x model, we can leverage the capabilities of the ZCU board, programmable logic support of the ZCU board, and create an optimized and efficient system. So these are some of the references that I would like to quote, and this is it from my side. Thank you.
Yeah, so very nice and very unique research, first of all. I don't have any question, but it's really nice and demanding research, I would say, for the upcoming society.
Yeah.
Okay.
Thank you so much.
Thank you. Coming up next, I would like to request Shreyas M. Vandkar to present his paper titled Object Tracking System on Zinc UltraScale Plus MPSoC ZCU104. Do we have you here with us, Shreyas?
Yes, ma'am.
Okay.
Can I share the screen?
Yeah, you can share the screen and I'll stop presenting.
Is my screen visible?
Yeah.
Just a second. So, good afternoon, everyone. My name is Shreyas, and I am here to present our work, Real-Time Object Tracking System on Zinc UltraScale ZCU104. Our co-authors are D.S. Sanjay, Prajwal, and Dr. Basaraj, who is even our guide. Now, coming to need for tracking, first we have to understand what is the need for tracking. The need for tracking of object arises from various applications. Just a second. The need for tracking arises from various applications and industries where it is essential to monitor, analyze, and interact with moving objects in real time, enabling tasks such as surveillance, navigation, automation, and human-computer interaction to be accomplished effectively and accurately. Now coming to the objectives, the first objective is to implement real-time object tracking system, and the second objective is to deploy the system on a target hardware, that is Zinc UltraScale MPSoC ZCU104 FPGA board, and the third objective is to analyze the implemented tracking algorithm. Now coming to the target hardware, this is the Zinc UltraScale ZCU104, which consists of a 4 quad-core processor and a FPGA fabric. The Zinc UltraScale ZCU104 is a development board created by Xilinx aimed to enable developers to prototype and develop embedded system applications. The UltraScale ZCU104 consists of Xilinx in-house built Cortex-A53 processor, that is quad-core processor. With its powerful processing capabilities and versatile I/O options and FPGA fabric, the ZCU104 is suitable for a wide range of applications. In embedded vision, computer applications, IoT, automotive and networking, and many more. Now coming to the tracking algorithm, we have used two types of tracking algorithm, that are KCF and CSRT. Now coming to the CSRT tracker, it uses correlation filter for efficient computation of target localization. It efficiently handles scale and translation variation suitable for real applications. It also provides robust tracking performance in scenarios with moderate challenges in appearance, scale, and occlusion. It is widely used in real-time applications such as surveillance, human-computer interactions, and robotics, where efficiency and speeds are paramount. Now coming to the CSRT tracker, even it uses correlation filter with channel special reliability checks, robustly tracks even when it undergoes significant transformation. CSRT strength is exceptionally tracking accuracy. CSRT is widely used in applications requiring high tracking accuracy and robustness. CSRT is more computationally intensive compared to KCF. Now coming to the implementation details, Xilinx HU104 consists of two parts, that is processing system and programmable logic. Our tracking algorithm is done in processing system, which consists of quad-core ARM Cortex-A53 cores. The first it starts with giving input frames, real-time input frames via USB camera, and after that we select the object to be tracked. After selection of the object to be tracked, we select the tracker, whether we have to use KCF tracker or whether we have to use CSRT tracker. After the tracker is selected, we have to initialize the tracking algorithm to get the output as tracking output. Now coming to the results. We can see the visuals of KCF tracker as well as visuals of CSRT tracker. Now coming to the first image, we can see when the object is inside the frame of a video camera, it provides a bounding box that it it provides a bounding box and also provides a message that it is tracking. When the object, we can see in the second image, when the object is out of the frame, it provides the message as lost, that the object the message as the object is out of the frame. When the object reappears in the frame, it provides a bounding box to the object and also provides that object is tracking. The same can be visualized in the outputs of CSRT tracker. When the object is inside the frame, it provides the bounding box and also provides the tracking message. And when the object is out of the frame, it provides the message as lost. And when the object reappears in the frame of the camera, it retracts the object by providing the bounding box and provides the message as tracking. Now coming to the challenges faced while doing this project. The first challenge was to internet connectivity for ZU104. The internet connectivity is required because we have to install libraries like NumPy, Pandas, and scikit-learn. So for this, we have followed tutorial given by Pink board that is provided by Xilinx. We saw the second challenge was we cannot use select ROI function to select the object because the GUI does not support use of select ROI function. So we had to manually calculate the bounding box parameter for the selected object. And for outputting the frames, we cannot use the cv2.imshow function for displaying the frames. So we had to use IPython display library to display the output frames. And the fourth challenge was there is a trade-off between accuracy and processing time, because CSRT is more accurate, whereas KCF tracker is more speed. Now coming to the future scope, we can use the programmable logic for optimization and efficient system. The whole tracking we have done is done in the processing system. So we can use a programmable logic for more optimization. And also we can add the recently arrived YOLO V9 for better accuracy. Thank you. So coming to the conclusion, we have successfully implemented object tracking on ZU104 with robust tracking algorithms such as KCF and CSRT filters. Thank you. Any questions?
Yes, so the question is how this presentation differ from the previous one. I think both look similar.
Just a second, sir.
But the author is also in your presentation, the person, yes, DS Sanjay is called.
Yeah.
So how this differ? Yeah.
He has you. Mine is real time. It is mine is real time, whereas it is uh, not a real time. I would say they are giving video as the input,
So
not
can't,
MP4 file.
can't we club these two paper together to make a strong for one paper?
But there are different algorithms that are used there. We are using correlation filters for tracking.
Because somebody is developing one paper in a topic, and then you cannot create another paper on a similar topic. So if there are more things, then you need to club them to prepare one single paper.
Okay.
This is just an advice. You can
Okay.
you are the author, you are the decision maker. How to go with that? So
Sure.
this
Sure.
small advice. Okay. Thank you.
Sure. Any other questions, sir?
No, thank you. I would like to request the moderator to proceed. Yes, madam. Hello. Madam, are you there?
Sorry, I got disconnected for a minute. Are we done with the presentation?
Yes, we need to continue with the next presentation.
With the next presentation. Okay. I'm sorry. I would now like to invite Sir Suresh Konitz to present his paper titled Technical and Economic Sustainability of Alternative Livelihood Strategies at the Grassroots, a case study in biased Karnataka, India. So, do we have you with us? Is my screen visible? Can anyone please answer me?
Ma'am, now it's visible.
Okay. Suresh, sir, do we have you with us? Your screen is visible. You may start presenting. You are not audible, sir. That is, if you're speaking, you're not audible. We are not able to hear you, sir, at the moment. You can,
Yes, so we may continue with the next presenter if
yeah,
possible.
exactly. That is what I was going to say. That I'll continue with the next presentation. You can fix your issues, and then we can take a presentation after this one.
We can take it at last after completion of all presentation.
Yeah, this one is going to be.
So you may proceed.
Okay. So I would like to request Prakhar Parekh to kindly present his paper titled Visual Speech Detection and Communication Assistant, a deep learning based approach.
Good afternoon. Am I audible?
Yes, you are audible.
Okay. I would like to share my screen. So if you can. Okay. Thank you.
Yes. You can share your screen now.
Yeah. Is the screen visible now?
Yes, the screen is visible now.
Okay. Just give me a moment. Sir, may I start with your permission?
Please do.
Okay. Good afternoon to the panel and all the participants. The topic is visual speech detection and communication assistant, a deep learning based approach. The authors of this paper are Mr. Parush Pulenia, Assistant Professor, MIT University, Noida, Aditya Raj Varshney, Devansh Rathi, Prakhar Parekh, Rudra Kumar Shukla. All the last four authors are pursuing their BTech in computer science from MIT University. The table of contents, introduction, background, methodology, dataset, results, and future work plans. Communication is a basic necessity of the human beings. We need safe, secure, and reliable mode of communication in an ever-changing world. Visual speech detection and communication assistant aim to bridge the gap in communication by harnessing the power of deep learning, which is a subset of machine learning that involves training neural networks to learn from many layers of representation of data, and computer vision, that is a field of AI. It involves developing AI to extract meaningful information from images and videos. Our deep learning based approach involves CNN, convolutional neural network, which is a deep learning architecture, and LSTM, by long short term memory, which is again an architecture of RNN, recurrent neural network. In our model, we have combined both these architectures to design a model that can help us in achieving the given problem statement. A lot of research has been done in this field, as lip reading has great potential, as it helps to generate transcript for videos with no audio. For instance, like CCTV cameras. Uh, Today, when we are seeing increased use of CCTVs to maintain law and order, to reduce crime, CCTVs do not have such powerful audio receivers that can basically receive the sound from a, let's say, in a crowded place. We won't be able to make any sense from the sounds the CCTV footage might even receive. Thus, this tool comes in handy because it helps us by generating a transcript that shows what exactly a potential individual which we are perhaps tracking, or whose conversation we want to know about, is speaking at a particular moment. It also simplifies the process of communication by providing clarity of message in noisy environment. And this assistant also helps people with special needs. We have analyzed multiple research papers from the past 5 years. The key research papers with prominent findings are listed here, as you can see. Just a moment. The research paper in 2018 has achieved accuracy close to human lip reading performance on short sentences. The one in 2019 introduced LipNet, a model capable of reading sentences in the wild. As you can see, a model in 2020 demonstrated the effectiveness of supervised learning, while the ones in 2022 have started analyzing sentences and generating a transcript accordingly. Now the methodology. CNN and bidirectional LSTM are a perfect pair for the given problem statement. As CNN is like a human brain, it has many layers. Our model primarily used 5 layers that are input layer. As the name suggests, the data is perceived by the model from here. The second is convolutional layer. It applies convolutional operations to input data. Basically, it uses filters to extract spatial features from input data that helps us in generating the transcript. Because by analyzing those features, the features here mean a particular hierarchical pattern in our facial movement. For example, if I say a word, let's say hello. So my face is showing a pattern, or the facial features are changing hierarchically. The third layer is the pooling layer. It downsamples the feature map generated during the previous stage by reducing the spatial dimensions while retaining the important information. The spatial map size is very large, and if we do not reduce it, then certain problems might arise. For instance, the model would take a lot of time to generate a transcript. So this layer is particularly very important. The fourth one is fully connected layer, also known as dense layer. Every neuron in one layer is connected to the next neuron. It's connected to every neuron in the next layer. This layer is very important, as the operations performed in this layer are used to map features extracted in all the previous layers. The fifth one is the output layer. As the name suggests, the information which we have received from the data set, the features are displayed here. Depending on the complexity of the data, we can also add 2 more layers, the normalization layer and the flattening layer. Again, if the data is too complex, then we might need to further reduce the feature table which has been generated by at the end of the model. So the normalization layer and the flattening layer comes in handy for that. The functions which CNN has performed in our model are, it has basically converted unprocessed visual data, that is the video which we fed to our model, into meaningful spatial representations by processing the static visual data. So to put it simply, it's working as a potential feature extractor. It is spotting hierarchical patterns that are seen when a person is speaking. The second one is bidirectional LSTM. Basically, it complements the CNN to a large extent. The temporal dynamics of the data are handled by bidirectional LSTM, as the name suggests, and also as shown in the figure, it goes both ways. The flow of info happens in both directions, thus improving the learning capability and enhancing the accuracy as well as the speed. Before using bidirectional LSTM, we tried to design the model with only long short-term memory. The CER, which is the evaluation parameter for the efficiency of the results, the character error rate, was 1.1. But after we implemented it using bidirectional LSTM, the character error rate improved to 1.6. The functions are as the functioning which has been performed by the bidirectional LSTM in our model is as follows. It helps the model to recognize the dynamic characters by modeling their temporal relationships. We have used grid corpus dataset for training the model. It's a 28 hours long dataset in which 34 distinct individuals have spoken 1,000 phrases in lab conditions where lighting, background displayed in the video, everything was under a strict control. 64,000 possible sentences had been created.
This is a gentle 1 minute reminder.
Okay. 64,000 sentences had been created, which had been analyzed by the model during the training phase. The rationale behind choosing this dataset, this dataset contains synchronized audio and video recording, which helped us to check the efficiency of the output of the model. It also includes re-recording from multiple speakers, and certain variations in background and lighting conditions were also present in the dataset, thus helping us to see how the model would behave in real world scenarios. The results have been calculated on the basis of character error rate, which is the evaluation metric here. It is calculated by dividing the amount of characters in the ground truth. The ground truth is basically information that is known to be correct, the transcript which was present in the dataset, by the least number of operations needed to convert the predicted text to the ground truth. The future work plans, because progress is continuous, are incorporating LRS, another dataset, lip reading sentences, and LRW to enhance the model's ability to work in various real-life situations. We are also trying to cooperate with our college authorities and multiple other organizations to get CCTV feeds on which we will try our model, which the model would again be fed with those CCTV feeds, and we will check the efficiency of the transcript generated, and it will also diversify the set of speakers. To conclude, the project amalgamates CNN and bidirectional LSTM. It creates a system that adaptly interprets spoken language from visual cues. To design this system, we have used the grid corpus dataset to train it, which the grid corpus dataset, as I mentioned before, has audio video recordings of diverse speaker in controlled and realistic settings. Here are the references. We are open to questions. Any questions?
Yeah, it's a nice presentation. No question from my side.
Thank you, sir. Thank you. Have a good.
Thank you, Prakhar.
Thank you.
I would now like to invite Sir Sorish Conant to present his paper titled Technical and Economic Sustainability of Alternate Livelihood Strategies at the Grassroots, a case study in biased Karnataka, India. Sir, do we have you here with us?
Yes. Can you hear me now?
Yes, I can hear you now.
Oh, okay, good. So I'll be sharing my screen now.
Yeah, please.
So is my screen visible?
Yeah, just a second. Yes,
Okay,
it's
full
visible.
screen.
You may start presenting.
Oh, okay, thank you. So I'll be presenting this study, which is a joint study among me and my colleagues from different departments and different campuses all over Ahmedabad University. So just as a quick introduction, so in India, rural areas are almost 20% of the population. And since the 90s, there have been lots of changes in terms of the agriculture, especially in terms of employment. Now it is estimated that about 200 million people have moved out of agriculture as their main source of livelihood, and 75% of rural households now live with monthly income of less than 5,000 Indian rupees. So there is widespread agricultural distress and changing climate patterns, which are making it more difficult for people living in rural areas to get a sustainable living. So they have to find alternative sources of income to ensure the financial stability of their families. And this is in spite of changing climatic conditions and a lot of challenges. So this study is exploring this challenge and taking the case of a community which is located in Shimoga district in Karnataka. So this is a community-based participatory study which was carried out to understand the challenges, the needs, and the requirements of these communities in terms of alternative livelihood sources, and also to propose appropriate solutions that can be both technically and economically feasible for the rural communities. So just a few words regarding the case study, the study area. So this study is about a village which is called Baise, which is in South Karnataka. It's about a little less than 1,000 people, 208 families. Agriculture is the main source of income. They mostly grow paddy and arecanut, and the climate is mostly rainy. So in this village, they have initiated to use arecanut leaf using a press machine to manufacture plates, which can be biodegradable and discardable. So they have tried this, but this is quite something which is quite challenging because the machines they're using are out of date. The manufacturing process is not efficient. The production is very low. So people are interested to develop this, but they don't have the knowledge or the means to develop it to a better level. So this is what this study is about, to try to improve the situation. So for the methodology, so this is largely an exploratory research study. So we have used an inductive approach. So we have used several participatory tools and collaborative activities to collect the data from the people and to understand the challenge in depth. So this is part of the Living Apps program, which is a program run by our university, wherein we get the opportunity to go and live in those rural communities to understand the challenge and propose solutions. So that was in two phases. The phase one was about understanding the community and the context. So we have used participatory appraisal and collaborative design, and we have used human-centered design to understand that in depth. And the second phase was about exploring the challenge more in depth and in two aspects. On one side, the technology, for which we have used a collaborative design approach to understand how to make things better, how to redesign it so that it is more efficient and also profitable. And another aspect is the business aspect, because it's about developing an alternative source of income, so it should be economically profitable as well. So how to market it, where to sell it, all these points are explored in that second phase. So now just presenting the quick results regarding this. So we did several participatory activities in the community, which were all centered around what changes do you want to see in the machine. So they had a machine initially which was not very efficient. What are the changes that they want in that machine? So that helped to understand the main pain points of the community, which were related to one, which is the difficulty to use the machine itself, and second, the difficulty to sell the plates that they have been able to produce at a fair price. So we have used the mind map to map all the challenges that the people have encountered. And this mind map is summarizing the problem that they face, the user requirements, and the proposed solutions. So this is the mind map summarizing the results. So the requirements, which are to use the hydraulic leg press, to have a dryer, the problem that they face, which are the availability of the leaves, the height of the machine, which is not designed as per the ergonomy of the people, the uneven heating, and also the poor marketing. And some of the solutions which have been explored, which are to how to increase the production, how to ensure there's a year-round implementation, and also the training of the target audience. So the problems and solutions are summarized in that table. So some problems are directly related to the design, and some problems are also related maybe to the training and also to the marketing aspect. So this is summarized over here. So based on these points, we move to the business sustainability assessment, which is a very critical part in that project. So the manufacturing of the plate is not enough, because unless they're able to sell the production, they cannot get actual benefits. So that's why it was required to investigate the business feasibility of not just manufacturing the plates, but how to take it forward to the market. So here the biggest pain points were that taking this production to the market is difficult. So one is due to the location of the village, which is quite isolated in the mountain, and the road is not very good. So this is logistical, practical problem. The second aspect is the lack of entrepreneurial spirit and the lack of expertise from the villagers on how to manage this aspect of the business, how to market it, where to sell it, how to discuss with the middlemen. They were not expensive. They can produce, but not much more than that. So, for example, the villagers found that the plates were sold at 4 to 5 rupees in some places. Initially, they were selling their plates at 2 to 3 rupees. When they realized that some people were selling at a higher price, they wanted to also get that higher price. But the problem is they were not able to provide the quality of more expensive plates. So we did a thorough study, market study, to understand and estimate what would be the optimal selling price so that they can get maximum profits, which is summarized in this graphic. So here we can see that though they want to sell it for 4 to 5 rupees, the price where they will get a higher margin, which is the most profitable for them, is to sell it from 2 to 3 rupees. So that is based on economics and statistics, where we discuss with different sellers, different buyers, different manufacturers in that field to understand what is the most profitable price. So just a few words for discussing that part. So technically speaking, so when we did the collaborative design workshop, it helped to determine all the shortcomings of the present machine, how it is designed. And so it's more than just the design of the machine, but there were some important business choices which were also affecting the activity. So the villagers can actually make this activity profitable in a number of ways. So we are here discussing 4 different options. The first one, which I just spoke before, is to sell the products, the plates, at a price of 2 to 3 rupees instead of 4 to 5, which is actually not at all feasible. The second option is to sell the leaves, the leaves themselves, to larger manufacturers as a raw material. So they don't even have to manufacture the plate. They can just sell the leaves as raw material. That avoids the labor cost. The third option would be to produce, but in a larger scale, so that they can get higher margin, higher profit. But that requires to improve the technical design and so that there is a less demanding manufacturing process, which can guarantee higher production capacity. So that is for that third option. That's the collaborative design
This is a gentle
which
one
we have
from my
proposed.
end.
Yeah, I'm from that. So that third option is the one which is explored with the alternative design that will be able to come up after this collaborative design workshop. And the fourth option is to create a cooperative so that they can operate this business as a community-based model. So as a conclusion, so this study just showed how the business and the technology can work together to develop sustainable livelihood opportunities at the grassroots. And the technical improvement alone cannot improve the livelihood. We need to have this business aspect as well. So similarly, the business approach alone cannot solve everything, because unless you have a machine which is technically sound and working and efficient, you cannot sell a product. So this study highlights how it is important to have a customized inductive approach when you're developing initiatives at the grassroots, and that it is essential to analyze the specific requirements of each community and also each users to derive solutions which are based on the actual needs and capabilities of the people. So that's it. I'm open for any questions that you might have. Thank you.
Yeah. A nice presentation. No question from my side.
Thank you, sir, for your presentation. And with that, we are done with the presentations for this session. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and all the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025 as well. All the presenters could be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2024. I also thank our session chair, Sir Kalpesh Popat, for chairing this session. This was a small token of appreciation for Sir from our side. And do you have any closing remarks for the participants?
Yes. First of all, I would like to extend my heartfelt gratitude to the entire organizing team for inviting me for this for a chairperson of this technical session. It has been an enriching and rewarding experience. I'm deeply honored to have been given this opportunity. I also express my sincere appreciation from the participants for the valuable contribution to our session. Your dedication for advancing the intelligence system through your research work is commendable, and I'm confident that your work will pay for the ground for the upcoming research. Thank you.
Thank you, sir. Now I would like to request everyone to kindly switch on your cameras for a quick snapshot of the virtual conference. Yes? Is everyone ready? Okay. 1, 2, 3. Thank you, everyone. Have a nice day.